Hi dear audience, this is Sharif. Today we will be calculating together the value of an imaginary quantity, a complex quantity, raised to the imaginary power. Here it is, we have, let's suppose we have x plus iy. This is a complex quantity, raised to an imaginary power, I. This is I also. Plus iy, x plus iy. How to calculate it? I think we rarely find a quantity like this, but it has a value. Mathematically, it is calculated. Electricity, it arises this value. Anyhow, let's not forget when it appears, this quantity, but how to calculate it. X plus iy to the power I. Here we have x plus iy, we all know x plus iy equals the square root of x squared plus y squared times e to the power I theta, where theta equals 10 minus 1, 10 to the power minus 1 of y over x. Okay. Which is equal to, let's call x squared plus y squared under the root is r. R times e to the I theta. This is our quantity here, but this is raised to the power I. Or what we did was x plus iy raised to the power I. R times e to the I theta raised to the power I. Now, r times e to the power I theta raised to the power I. How to calculate it? So simple. Let's here root minus 1 r to the power I times e to the power I square theta.
Raise the two quantities to the power I.
It's becoming easy here. R to the power I times e to the power minus theta. I being the square root of minus 1, so I square would be minus 1. So this is our quantity. How to calculate it? Still, how to calculate r to the power I? So simple. Here, any number, any quantity, you know, x or a, whatever. A could be written in the form of e to the power ln a. E to the power ln a equals a. X equals e to the power ln x. Okay, this is, let's write first r. R is e to the power ln r to the power I times e to the power minus theta, right? Okay, so this is e to the power I ln r is cosine ln r plus I sine, the same thing with the sine, sine ln r. E to the minus theta all over e to the power theta. So this is our quantity, where 1 over e theta stands for.
Now here, our expression, complex expression, raised to the power I yielded to this expression, cosine ln r plus I sine ln r over e to the power theta. Actually, this expression represents the 1 over e to the power theta, that is 1 over the denominator. Actually, 1 over e to the power theta represents the scalar value of the vector. 1 over e to the power theta equals a, that's it. And phi equals 10 to the power minus 1 of 10 ln, as here cosine ln r, where r equals the square root of x squared plus y squared. So phi equals 10 to the power minus 1 of 10 ln cosine ln sine ln r over cosine ln r, that is 10 ln x square plus y square, which is r equals to the square root of x square plus y square. That's it. I hope things are clear now, and our complex quantity would be represented by this vector making an angle phi.
So simple, so easy. Bye.